Hello, this is Dr. Lukes. I wanted to go over our instructions for the written lab reports for our unit operations courses. So there are two types. The first is a formal report. A formal report is going to be formal, as it's stated. You're writing this to an audience that is like the CEO of a company, someone you want to really impress. You're going to use formal language. You have no idea who all this is going to get passed forward to, so it needs to be a complete document. Everything needs to stand alone in this document, okay? You're going to start with the cover page. The cover page needs to include the title of the experiment, the date the experiment was conducted, the date that the report is due, and the names and roles of everyone on the team, okay? Now, it's only worth 1 point, but all those elements need to be there in order to get that point. The next item is going to be the executive summary. Now, although this comes early in the report, this will be the last thing that you write. It can either go at the bottom of the title page or it can go on a page all by itself following the title page. It is a brief summary of the objective of the experiment with your final results and conclusions. And I do want those there. Be specific. Don't try and be cutesy and coy and say, read the report to get more. No. You should be able to read the executive summary and come away with the big picture takeaway for this report. Okay? The tone is very formal. You're not going to use contractions. You're not going to use those personal pronouns, I, we, etc. Okay? That is worth 3 points. The table of contents will be next. Table of contents needs to include all the sections and a list of the tables and a list of the figures with page numbers. Now this needs to be on a page, started on a fresh page. Usually it's only 1 page, and so it's the only thing on that page. The most important thing though is that you must, or the thing that's most often forgotten, is that you must include those tables and figures with their titles, okay, and page numbers. Then you're going to start yet another fresh page, and this is going to be where you begin the body of the report. You're going to start with an introduction, or maybe you would rather it be a statement of objectives. Either way, you're going to, this is the beginning, right? Every report gets a beginning, middle, and an end. This is your beginning of your report, okay? It needs to tell people what is going into this report, right? It needs to motivate why on earth anyone would be reading this. The objectives of the experiment is a good way to do that, but you may wish to add in some background for why this is important for chemical engineers to understand this concept, okay? Now, the next section is the theory. So you want to give the theoretical background. It needs to be appropriate for someone who has a technical background. Remember, you're writing this basically to the CEO. They have a technical background, but they probably haven't used it in a while, and so you need to give a refresher. You don't want to talk down to them, but you want to make sure that it is complete enough so that they really do see the theoretical foundation of what it is you're doing. Okay? Obviously, the content needs to be correct, and it needs to be logically presented. When you are doing equations, tables, and graphs, be sure that they are well formatted. Equations always need an equation number off to the right-hand side. Okay? That's very important because later when you refer to it, you're going to refer to equation 1, not the equation above. Okay? Let's try and remove above and below from our language that we're going to use in these reports. Okay, as things get moved around and reformatted, the aboves belows end up being wrong, and it's just excess worded. So use equation numbers, table numbers, graph numbers. The next section is the experimental design and procedure. This is where you're going to explain what you did in the experiment. You have completed the experiment by now, so this is all past tense. And it's an overview. You want to be specific about like what equipment did you use, okay? Give me a model number on that pump, etc., okay? But you don't need to tell me step by step how to do it. I'm not going to be imitating your experiment based on this, okay? I want to know that, well, we measured this and then we measured that, and then we repeated in this order, we chose things randomly, those kinds of things that show that you have good experimental design, okay? You also want to present what that data was. So you did the experiment and this is what we got. Okay. Now again, you're doing this all in that formal language, so it's third person. So very much passive voice is going to be true here. I find that a lot of students really struggle with this particular section because you want to write a operations manual. That goes in a pre-lab report. That does not go in this final report. But you do want to give those specifications on what equipment, tell me what diameters you were using if you're studying various tubes, etc. Okay. Your experimental results, you measured certain things. So maybe you measured volume and a time, and now then you're going to turn those into, say, a mass flow rate, okay? So those calculations are the experimental results. So it's not just the raw data, it's how you manipulated that raw data, okay? Now, I'm going to be looking to see that your calculations are correct. You should be able to point back to, say, equation 1 was used to, take this data and calculate this quantity, okay? You want to be sure that you present error limits here, okay? Even on the very earliest reports, I am very harsh if you do not give me error limits. Now, this may be, the error from the reading, so the last digit that you can read on the meter that you had. But it may be propagation of error is required here because it came through calculations. All right, we're going to talk more about that in a later video, but that all needs to be part of your experimental results. Okay. Now, the quality of data is not a section of the report, but at some point I need to be able to evaluate whether or not you did the experiment properly, whether you used proper care, etc. The next section, and this should be probably the largest section in your report, is your discussion and your engineering analysis. So this is where you're going to demonstrate that you technically understand the meaning of that data. You can relate it to the theory. You can say what did and didn't match. And if it didn't match, propose a reason why it didn't match. Okay? You want to discuss the error in the statistical analysis. So when we talk about propagation of error, you should be able to say that, well, the volume measurement was the one that really created the most error. The time, was not so important in this, and have numbers and calculations to back it up. Okay? If there were specific questions posed in the lab handout, then you would want to address those here, but don't say question 1 and then answer it. You're going to just blend it into the report. And sometimes some of the questions may not really apply to what you found, okay? Those questions are a guide so that you can, to help you write a more complete report, all right? But be sure that you are tying your theory to your results, and you are showing some, critical evaluation of those results here. All right? Then there's 10 points for format of figures and tables, and I will have a video over that also. Okay? So figures have a title that goes below the graph. You're not going to have a title in the graph and below the graph. Okay, that's bad form. There's a lot of rules on that, and I'll have a separate video on that. Tables have a title that goes above the table. Now, when you're in doubt on what format to use, look at a technical journal. That's going to be your style guide. And if you can find me a professional technical journal that uses a style you have, and if I took off points and you find something that uses that style and it was, a quality journal, then I'll give you those points back. All right? In general, when you're choosing between tables and graphs, usually a graph is going to present that idea better. So if you can create a way to put that information graphically rather than me looking at a table full of numbers, I'll probably get the idea, the point of what you're trying to tell me a lot more efficiently. And then you're going to wrap up your paper with conclusions and recommendations. So again, you're demonstrating technical understanding with the conclusions you draw. Okay? You're not going to be presenting new information here. You're going to take those most salient information out of that discussion and engineering analysis section, and you're going to pull that into your conclusion. When I say recommendations, it's your recommendations for next steps. It's not recommendations for, well, we should have had a bigger this or a, it's not the whining, okay? Those aren't your recommendations. Your recommendations might be that, oh, we learned that the tank will drain faster if I do X, and so therefore, if I want to quickly drain a tank, I need to, okay? That's your recommendation. Again, no whining, all right? This is a professional quality report. No whining, okay? Now this should be concise. It should be comprehensive, okay? Now then you're just going to wrap things up. So you've got references, okay? On the references, if you use any style that you would have found in a textbook or a professional technical journal, I'm going to be good with that style. Just use a consistent formatting and have the correct information that goes with a reference, okay? The nomenclature section, this is something you probably haven't done before, okay? You're going to list every symbol used with what its meaning is and possibly the units associated with that. They're going to go in alphabetical order, English alphabet first, and then other languages go below that. So usually Greek is the other language that we use. But again, alphabetical order, this needs to be complete. If you used a symbol in your report, it needs to be in the nomenclature section. Normally, we're going to kind of indent, we're going to use a lot of white space. White space helps draw the eye and makes it so that these things are going to be visually appealing. People like reading those reports. They're not going to be finding so many little nitpicky criticisms when you've given them a visually appealing report. You're going to conclude with the appendix, which is sort of the gathering place of all those things, like a sample calculation should be somewhere that's available, okay? Any data analysis you did, so when you are doing statistical analysis, that should be there. Maybe you used some graphs as a step in your calculations. Those graphs should be there. Anything that really didn't make it into the body of the report, but you think that someone might want to look at, never put anything in the appendix that you force the reader to look at, okay? If they have to go into the appendix to make the body of the report make sense, you did it wrong, okay? But anyway, so this is just sort of your collection of the extra for experts kind of stuff, all right? So now your report's finished. The last items here, style and grammar, it's only 10 points, but this is a big deal. You need to write with the appropriate formal language. You've got all those tenses correct, okay? So the experiment has been done. It's in the past, okay? But the results still exist, okay? You wrote it for the right audience. So it's like a technical executive who kind of knows something, so you don't want to talk down to them, but they also probably don't really know the details, so you need to give them enough information, okay? And you're going to be very formal and proper. You're not going to use slang. You're not going to use contractions. You're not going to use those first-person pronouns, etc., okay? Now, I have this last category here, which is format and appearance. This is negative points only. I promise you, every time I catch a spelling error that spell check would have caught, I'm taking off -1. But I also take off -1 for first person pronouns, for general ugliness, for turning in a final report that still has track changes or comments and stuff left in there, or XXXX because I was going to put in a page number here and I forgot to ever get around to it. Those things go into format and appearance, and I just take -1 for each one of those. Okay? So that's going to be your formal report. So the other type of written report we do is calculation memos. Calculation memos are going to be more casual. This time your audience is your supervisor, okay? Someone you work with on a daily basis. You are comfortable conversing with them. They still are making that decision about whether or not you're going to get that raise or promotion next year, okay? But you know them well. They assigned you this task, okay? They know what it is that you are talking about. They'll want a little reminder about it, but you know this person. You do not need to be super formal with them. Those first person pronouns are good here. If you're too formal, it's going to sound stilted and it's going to be off-putting. That's not really good for your career either, okay? So being able to choose the correct audience and the correct writing style. So the calculation memo. So first of all, it is a memo format. Memo format says to, from, subject, date. Okay. There's usually a line underneath that, and then you start the body of the report. You don't need to use headings. You can if you wish. Okay. You do not put a salutation, and you're not going to wrap up the memo with signatures either. Okay. It's just the body of the report goes underneath that memo block and the line. There are a lot of templates that you can find out there on the web if you don't know how to create a memo. Okay. So you're going to start with an introduction paragraph. Now remember, the audience is your supervisor. They asked you to do this, okay? So you need to give them a statement of what the objective was as a reminder, because they've got a lot of other things going on too, okay? But you don't need to give a lot of background information, okay? You don't need to go through the theory because they're in the trenches with you on this, okay? So you're just going to remind them of what it is that they had asked you to do. Okay, and then you're going to present your results. You're going to give a link that's going to go to where the data is and so forth. You may wish to provide a little bit of information on the procedure. Not necessarily. It depends on what the experiment is as to how much you need to say about procedure here. Sometimes a line or two, because maybe you had a choice of doing technique A or technique B. You made a decision, so you want to put that into the report. Okay? But generally, you're talking about just those calculated results. Okay? You're going to attach a sample calculation. I need to see that, okay? But you really don't need to present the theory. You might need an equation if it's something that, like, you developed an equation in this experiment, then you'll do an equation, okay? You do want to give any significant assumptions that you made. So maybe you assumed that there were no friction losses or something like that. That's going to need to be in the report. Otherwise, the calculations are not going to make any sense. The discussion, so what meaning are you drawing? Again, you want to show that you're technically competent, okay? And you want to make sure that you're including that statistical significance. Now, I have not specified it here, but you also need to include that error analysis. You always want to give error limits. Every time you give a technical value that you have measured or calculated, you want to give, based on your experiment, what are the error limits, okay? Again, here's a place for evaluating the quality of your experimental work. And then the appendix is going to be those sample calculations, your data analysis, etc. Okay, so the general grammar and style here, not as formal as a formal report, right? A little bit chatty, but not overly. You don't want to waste people's time with chatty, okay? The intended audience is your direct supervisor, the one who assigned the work, okay? They are technically knowledgeable, okay? You do want it to still be visually appealing, so don't crowd things. Use correct grammar and spelling. Keep it brief, okay? Try to tighten your language, okay? And this is going to be, like I say, not too formal. That's really the thing that, people start by writing something that's so chatty that it's like, yeah. Okay, and then they end up switching and going overly formal. You want to find that sweet spot there, how you're going to be impressive to someone you know. Okay, so those are our two types of written reports. We'll come back with some of the details in future lessons. Thanks.